Hello students, if you want to see my introduction video, it will play in the last 1 minute of this video, and if you want to see some of my other videos, you can get the link in the description of this video. Now this is my second video on this topic, permutation and combination. In the first video, I covered the exercise 7.1 in which I explained about the multiplication rule and the addition rule. That means the fundamental principle of counting, and I covered the numericals based on that. Now in this exercise 7.2, there is just one concept involved, and which is very simple and small concept, but it finds a lot of application in the later exercises. So let's see what this concept tells us. This is factorial notation. Factorial notation, what it tells, factorial n or n factorial, we write in these three ways. Basically, either we can write factorial n or this way, or we can denote it by this. Factorial n is a continued product of first n natural numbers. Natural numbers are what? They are 1, 2, 3, 4, 5 and so on. So when we say continued product, it simply means 1 into 2 into 3 into 4 up to n. So n factorial is equal to 1 into 2 into 3 into 4 and so on up to n. For instance, what is the application of this? If we write 6 factorial, it means 1 into 2 into 3 into 4 into 5 into 6. We can also write it in the reverse way. That means 6 into 5 into 4 into 3 into 2 into 1. We will see later on how it is used and where it is used. Reverse way of writing this factorial notation. So basically it simply means that continued product of n natural number is n factorial. Now there is an important observation in it. Okay, if we have to write in the reverse this particular thing, n factorial, we have written it as 1 into 2 into 3 into 4 up to n, and in the reverse if we write, it will be n into n minus 1 into dash 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 into 4 into 3 into 2 into 1. I have told in both ways because we will use it in the question. Both ways are used in the question. If we have to calculate the value of factorial, then we write simply 1 into 2 in the proper order, and if we have to solve some other questions, some equations if we have to solve, then we will find use of this particular notation, the reverse order. Let us see how. Now there is an important observation in it. For instance, if I say 6 factorial, it means 6 into 5 into 4 into 3 into 2 into 1, or else I can write 6 factorial is equal to 6 into 5 factorial. Now this makes this whole unit 5 into 4 into 3 into 2 into 1 makes what? 5 factorial. So if you remove 6 from this whole product, it will make the product as 6 into 5 factorial. We can also remove two numbers from this product. We can say 6 into 5 into 4 factorial. So basically this is here, this is the place where this particular reverse order finds application, that if we have to break it, or if we have to write it in this way, a bigger factorial has to be broken into a smaller factorial, then this particular order or the reverse order is used. So I can also say, if I am talking about the general way, this I have given a numerical example so that it is understood easily. Now in a generalized form, if I have to write, it will be n factorial is equal to n into n minus 1 into n minus 2 into and so on up to 4 into 3 into 2 into 1. This can be written as, if we separate this n, then the remaining portion will be n minus 1 factorial. Or we can remove these two, n into n minus 1 into n minus 2 factorial. Or if we remove these three, it can be n into n minus 1 into n minus 2 into n minus 3 factorial and so on. So this is how we can break a bigger factorial into the smaller factorial. This will find application in problem solving. We will see in the exercise questions. And this one last concept in this particular topic in factorial is that 0 factorial is equal to 1. We need not to go to the depth of it. There is nothing like proof or something. It is by definition. It is defined as such. This concept finds a mention in the book, so I have mentioned it here. It has no particular, not much use in class 11 maths. So just we should know this concept, 0 factorial is equal to 1. It is defined as such. So with this, there's nothing more in this factorial concept. Factorial, I'll again tell you, factorial is nothing but a continued product of first n natural numbers. Now when we'll solve the exercise 7.2, the application part will also be clear. So let us solve questions of exercise 7.2. So let us see the first question of exercise 7.2. Evaluate 8 factorial. So it's very simple. We'll write 8 factorial as 1 into 2 into 3. It's a continued product up to 8, 1 to 8. So 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. So we'll work it out. It will come to 40320. Then the next one is 4 factorial minus 3 factorial. Now there are two ways of solving it. One, we can simply find out the value of 4 factorial and value of 3 factorial, and we can subtract this from this. So this is how it is done. 1 into 2 into 3 into 4 minus 1 into 2 into 3. So it comes as 18. Now the second method is, in this we can take it as 4. We can write 4 factorial as 4 into 3 factorial. We have just seen this. This is the way we can break a bigger factorial into a smaller one. So 4 factorial can be written as 4 into 3 factorial, and this is 3 factorial. So we can take 3 factorial common. See, if we observe this thing, 1 into 2 into 3 can be taken out as common factor from these two terms. So that is the same thing we are doing here in factorial notation. 3 factorial we are taking out as common. So 3 factorial, 4 minus 1 is, which is 3. 3 factorial into 3, which is 1 into 2 into 3 into 3, which again gives the answer as 18. So question 2, they're asking, is 3 factorial plus 4 factorial is equal to 7 factorial? There's nothing big in it. We just have to calculate 3 factorial plus 4 factorial, which comes to 30, and RHS is 7 factorial. We'll expand it. We'll write it as 1 into 2 into 3 to 7, and this comes out to be 5040, and obviously LHS is not equal to RHS. The third question is, compute 8 factorial upon 6 factorial into 2 factorial. So we'll break this 8 factorial. Now we find in the denominator there is 6 factorial. So we'll have to somehow bring numerator also in the form of 6 factorial, so that we can cancel out 6 factorial from numerator and denominator. So yes, we can do this. 8 factorial can be written as 8 into 7 into 6 factorial. So 8 into 7 into 6 factorial, if we write, this will get cancelled out with the denominator, and the remaining portion will be 8 into 7 in the numerator and 2 in the denominator. So finally the answer is 56 upon 2, which is 28. The next question is, if 1 upon 6 factorial plus 1 upon 7 factorial is equal. Now this is equation type of question. Again, we have to find the value of x, and here again we will use this 6 factorial is the smallest factorial here. So we'll write other terms, the bigger factorial in the terms of 6 factorial. So here we'll write 7 factorial as 7 into 6 factorial, and in the right hand side we will write 8 into 7 into 6 factorial, so that we can cancel out this common 6 factorial from all the 3 terms. So we are left with these terms. On the LHS we have 1 plus 1 by 7, and on the RHS we have x upon 8 into 7. So now again, if we simplify it further, we get x is equal to 64. The next question is, evaluate n factorial upon n minus r factorial. Now they have given a expression, and in this expression we have to put the values. N is given to us and r is given to us. So here in the first case, n is equal to 6 and r is equal to 2. So n factorial upon n minus r factorial will give 6 factorial upon 6 minus 2 factorial, 6 factorial upon 4 factorial, which is nothing but 6 into 5 into 4 factorial. This 4 factorial will cancel out from numerator and denominator, and we'll get 6 into 5 is equal to 30. And the last one, here n is equal to 9 and r is equal to 5. If we put it in the given expression, so in the numerator we have 9 factorial, and in the denominator we have n minus r, or 9 minus 5 factorial, which is 9 factorial upon 4 factorial. We'll solve it like this. We'll break it into this form: 9 into 8 into 7 into 6 into 5 into 4 factorial. Again, this will strike out, from numerator and denominator, and we'll get the answer as 15120. It was a very simple and small concept, but it will find a lot of application in the later exercises. So this is all in exercise 7.2. So this is all in this lecture. Hello students, I am Anurag Gupta, MBA Finance, a topper of University Department Pune, and I am also a CFA from ICFAI University. After spending a few years in financial sector, I left a lucrative corporate career to pursue my passion for teaching. I have been a top ranker in various exams at school, college, university, and even at all India level. And I have consistently produced top rankers from my institute for the past 8 years. And here I must mention that many of my students who were average performers till their standard 10 exams showed excellent results in their standard 11 and standard 12 exams, and even now they are doing really well in their respective careers. Now, with a view to spread my knowledge to the maximum possible students, I have started teaching in online mode as well. Initially, I will bring videos on maths, accounts, economics for the students of class 11 and 12, where I'll cover the entire syllabus in a very systematic way. I'm sure you'll enjoy the process of learning in my lectures. So welcome to my channel.